Hello everybody. Today we're gonna learn something about a frame. It is a structural member. Let us start from a simple frame. Let us suppose a frame with one in hinge and next in roller. As I told before, we are going to start with a simple frame. So let us suppose a point load. Let's say 1 kilonewton, and from lateral load as well 1 kilonewton. Let's have some dimensions. 2 meter, 2 meter, as a whole 4 meter, 2 meter. Let's keep let's say this point as A, this point as B, C, D, E, and F as here is no load. So first step solving a frame is, first step is always calculating a reaction for any member. As you see here is a hinge, so hinge carries a two-way reaction, that is reaction upward and lateral reaction. Let's say this is VA and this be VAX and this be VF. So let's say this as VAX and this VAY and VFY, as it is in y direction and it is in x direction. So first of all, for calculating a reaction, you can have a three method of static equilibrium, that is summation fx equals to 0, summation fy equals to 0, and summation moment equals to 0. Now by using these three equations you can calculate the reaction. Let's take moment about A. Moment about A, by using this moment about A goes to 0, you can calculate the reaction Pfy, and you can take anyways moment is not concerned. Let's take clockwise positive this time, and this 1 kilonewton, as you're taking moment about A, this 1 kilonewton will also have moment, and this 1 kilonewton will also have moment, and this reaction will also have a moment. So these three are the forces. Now let's first calculate for this. 1 into perpendicular distance 2, and from here it rotates clockwise, so it's positive. Again for this 1 kilonewton, from here it rotates positive and its perpendicular distance is 2 meter. And this line of action is this, and this distance will be 2 meter, so it will be plus 2 into 1. And Pfy, for Pfy it would be anti-clockwise moment about A, as it rotates in this direction, and the distance between them is 4 meter, that would be minus, and there is no other load, so it will be a 0. On solving it, Pfy we get 1 kilonewton. Now let's use, we already used this, so let's use now in Fy direction, that is vertical direction. That means Pay plus Pfy is equals to, the vertical load is only 1 kilonewton, so you can say as 1 kilonewton, as we already got Pfy, so it would be Py plus 1, or let's give 1. Now we come to the next step. Let's say step 2. In step 2 it will be a free body diagram, and in free body diagram we'll separate each and every member. Let's say this A, and this member, as you observe in the figure, here will be member B, and here is member C. At least C here, because these two members as a whole indicate the C, and here is the D, that is 1 kilonewton, sorry, here is the D, and at this point I press E at here, that indicates the double member, and F at here, and here we came with a reaction 1 kilonewton, and here with reaction 0, and here with reaction 1 kilonewton, load 1 kilonewton. Now first of all, it's step for free body diagram. Step 1 is first force should be balanced, and step 2 is moment balancing. Now first we should follow the first step at the first. 1 kilonewton load at here. Oh sorry, it's minus 1 at this position. 1 kilonewton load at here, minus 1 at here. That means this both neutralize each other. That will be here at 0 and 0 is here. That means we place 0 at this position for our origin is 0 in this side means 0 at this side as well, and 0 from this side, and here will be this load as well also 0. 1 kilonewton from this side means we need here 1 kilonewton for balancing it. 0 at this side means 0 at this side. 0 at this side means 0 at this side, and 1 kilonewton upward means 1 kilonewton downward will be in this section. 1 kilonewton down and 1 kilonewton upward, they both neutralize each other. Now force are neutralized. Now we need to calculate moment for each and every section for drawing bending moment diagram. The shear force diagram can be obtained from this free body diagram. Now for bending moment diagram, we need to calculate moment for each and every section. First of all, for section B, calculating moment for section B is only due to the 1 kilonewton load. To calculate the moment at B, it's not really necessary, but we can also calculate for it easiness. So we'll go direct to point C to calculate moment at point C. As it is a point load, it's a simple structure, so we are not going to do a complex calculation for it. So we're going to calculate moment at C. Let's say moment at C, it will be due to this load and this load. Remember my point, it will be due to load at point A and load at point B. At point C, due to load at -1, it will be a anti-clockwise moment at C. That means C is rotated in anti-clockwise. That is now -1 into this whole distance. This whole distance is 4, as it is given in our structure. You can see clearly here this distance is 4, and this is anti-clockwise direction, and due to 1 also it will be a anti-clockwise direction. At minus is here, so I mentioned -1 at this place, and here is +1, so I mentioned +1 into this perpendicular distance between force line and that point. That will be 2. 4 plus 2, that means -2, and its anti-clockwise moment. -2 anti-clockwise moment, that will be, we can say it 2 kilonewton meter clockwise moment. We can say 2 kilonewton clockwise moment, as clockwise and anti-clockwise just differ by minus. So to balance at C, we have got 2 kilonewton clockwise moment. For balancing at C, we need to place 2 kilonewton anti-clockwise at C. That is 2 kilonewton meter. At this point it's 2 kilonewton meter, so to adjust it we need here 2 kilonewton meter in clockwise direction. Now our next target will be point E. Let's calculate moment at point E. Moment at E, that will be due to 2 kilonewton as well as due to this 1 kilonewton load. 2 kilonewton is rotating about the E in clockwise direction, 1 kilonewton at anti-clockwise direction. So it will be 2 kilonewton meter moment shift at E, and by D it will be minus, as it is rotating it in anti-clockwise direction, so it will be 1 into 2. That will be 0. 0 means you don't need to specify the direction, so I'm placing here 0, and here 0, and here is 0. At roller doesn't roll any moment at free end. Now for diagram. First you need to draw shear force diagram. Secondly you need to draw axial force diagram. Thirdly you need to draw bending moment diagram. Now first of all I'm going to show you the shear force diagram. Just observe the free moment, free body diagram. This is our structure, and -1 at here, that means 1 kilonewton load at from this point. We can say it 1 kilonewton from this point. So at this point it will be 1 kilonewton, 1, and at this point 1 kilonewton is neutralized. At this P point 1 kilonewton will be 0. That means this is the diagram for this place, and up to here it will be 0, 0 as you observe here, and at this point you get it 1 kilonewton, and I'm sorry, it will be not here one. First of all, we have to go by from this side. Here we got 1 kilonewton, so we need to take it first. I'm sorry, I reached at this place. Here 1 kilonewton it will be, and it will be up 1 kilonewton up to this place, and at this place it will get neutralized by 1 kilonewton load upward. So it will be like this, and it will be a positive shear force diagram. It lies above the axis and it lies below the axis, so it will be negative shear force diagram. And for hatching it, I didn't mention here anything because here is no any shear force load that is perpendicular to axis, no load, so I didn't mention at this place. And the hatching is always perpendicular to axis. In similar pattern you can have. And this is your first diagram. Now we go to the axial force diagram. The axial force diagram, you need to observe the figure. Axial force diagram. Axial force diagram is a compressive force or tensile force. You can see here 0 0 compressive force. That means it is compressing the member. So here is 0 0. No need to mention. At this point also you get 0 0. That is tensile member. And it's 0 0. So it's no need to mention. Here is 1 kilonewton. And here is 1 kilonewton. That is compressive member 1 kilonewton. So it will be figured like this, and compressive member, so it's negative and perpendicular to axis hatching. Now we come to bending moment diagram. Now we come to the bending moment diagram. For bending moment diagram, we need to consider the structure. A, C, E, F. And this is C, F. We come at here. For the bending moment diagram, you need to observe figure carefully. Bending moment diagram at A will be 0 as it is a hinge support. So here is 0. And at point C, you see bending moment diagram is 2 kilonewton and it's anti-clockwise. Anti-clockwise, we need to plot inside. So here come 2 kilonewton. And you just join the member with this, and 2 meter. Here will be B, and here is the load, and it's anti-clockwise, so if we assume anti-clockwise as a negative moment, and hatching the same way perpendicular to axis. Now we come to this point. At this point 2 kilonewton is clockwise movement is upward. So here is so it's suppose here is 2 kilonewton meter, and at this point it's 0, so it will be just similar pattern as AC, and its positive moment related to hatching at this pattern perpendicular to axis. It's a bending moment diagram. Now here we complete our calculation, and subscribe for more. Thank you.